So our another advanced SAT subject math level 2 trigonometric function problem will be solve for sine of 2x when cosine of x is equal to negative 2 over 3 and pi over 2 is less than x and x is less than pi. So as we can see here, if we see the word sine as well as the cosine, we might think about one thing that we learned in the last few videos. It will going to be a trigonometric function. So the sine and the cosine is related to a trigonometric function. So this question will be the advanced trigonometric function problems. And if you go more further, what we learned, what we need to do or know in order to solve for this question, we know that there are both sine and a cosine. So for a trigonometric function, so if you write it down as the trigonometric function, for a trigonometric function, there are totally two types of questions in our trigonometric functions. There are two things we need to do in order to solve for our question. The first thing will be our triangle trigonometric values, which means apply our trigonometric functions to our triangle. But what is the triangle especially? It is a triangle with a right angle, which we call it as the right triangle. And we can apply our trigonometric function to either right triangle, or secondly, we can apply it to our graph of our trigonometric function problems. So we need to define whether we apply our trigonometric function to our triangle, which is our right triangle, or our graph of our trigonometric function problem. So let's go back to our original question. And the question is sine of 2x. And when cosine of x. If you see the brackets between these trig functions like this and this, there are brackets and there are x values, specific variables. That means they are the angles. There are the main angles, which is our x degrees. That means this will turn into our triangle trigonometry. What is our triangle trigonometry? We are applying our trigonometric function problems, trigonometric problems, to our right triangle. So as we can see, we are trying to solve for the trigonometric function values that we need to apply to our right triangle, and we could figure that we are applying this to our right triangle because they gave us the specific angles through its variables. And so this is our values that we need to solve. And what is the most important thing in our triangle trigonometry? What is the most important thing in our triangle trigonometry? Well, the most important thing between our trigonometry that differs from its value from our trigonometric function will be, firstly, it will be our right triangle. And people might think that why do we need to apply our triangle trigonometry to our right triangle? Well, we're going to explain a little bit more detail as we solve this question. But we know that the origin of our triangle trigonometry was originated from our Pythagorean theorem, the theorem that was built by a Pythagorean. So we know this Pythagorean theorem. And what is the most important thing in our Pythagorean theorem? The most important thing in our Pythagorean theorem will be the lengths of our sides. And the right triangle, it has the specific angles and the sides that are proportional with each other, not like other triangles. So that's why we are applying our triangle trigonometry as well as Pythagorean theorem to our right triangle. And what is the next thing after the right triangle that is important? Well, it will be an angle. What angle exactly? The main angle. The reason is because the main angle will be the thing that defines our types of our graphs, our trigonometric values, depends on its size or locations. And so we need to think about the angle first after we apply it to our right triangle. So if we kind of make a sense to ourselves or remind ourselves what is this question about visually, not by writing. It will look something like this. So we will need a simple right triangle. More advanced trigonometry is to apply our triangle. Apply our right triangle into or in the coordinate plane. What is the coordinate plane? It is a plane that is formed by either horizontal line or a vertical axis. So let's go and draw it. There is our coordinate plane that we need to draw the x-axis and the y-axis, horizontal axis, and the vertical axis. And there can be either there should be 4 types of triangle we can apply in our triangle trigonometry. The first type will look something like this, because the data which will going to be our main angle, let's say, should always be located somewhere in our quadrant, and let's say our main central angle is right over here. This can be 1. Where the 90 degree should always exist, and it is right over here. And the second triangle we can apply in our triangle trigonometry will look something like this. But we need to remember that the line that should be the inner legs of the legs in our triangle trigonometry should always be parallel to our y-axis. And we have our right angle, and if you just say that this angle is our main angle, the another form of our triangle trigonometry will be formed. And this is 2 types of our triangle, and if you flip this to the another side, then we're going to create 2 more, which we're going to give us totally 4 types of triangle. So using these 4 types of triangle, we need to solve what this question is basically about. And our ultimate question in this case will be solve for the sine of 2x. So we need to solve for a sine of 2x using these 4 types of triangle and see what is the right answer. And in order to solve for this question, using our Pythagorean theorem as well as triangle trigonometry, we have 4 things to know in order to solve for this question. Well, this question is basically to solve the sine of our 4 types of triangles, which means we need to learn our triangle. So the first thing we need to learn is triangle trigonometry values. And what are the things that are triangle trigonometry? Well, they are sine, cosine, as well as the tangent. So our first thing that we're going to talk about more in detail in order to approach this question will be properties of triangle trigonometry, which is the values of sine, cosine, as well as tangent on our triangle. First thing that we're going to talk about is our sine, cosine, and tangent. And what is the most important thing again in our triangle trigonometry? Well, so when we talk about the values of our triangle trigonometry, so when you talk about triangle trigonometry values, the most important thing that we need to always remember in our triangle trigonometry or either triangle or trigonometry function is that we always need to apply this to our right triangle. So if you want to apply our trigonometric functions or triangle signs, which is firstly, there is sine of our x degrees, and secondly, there is cosine of our x degrees, and lastly, there is tangent of our x degrees. So what we do, when you see that we're applying these numbers to our trigonometric function, we're applying this to our right triangle by labeling every single size. So let's bring our triangle, our right triangle, and apply our trigonometric function problems. And the most thing we need to remember is that when you apply our sine, cosine, and tangent to our trigonometric function, we always need to bring our right triangle. That is the most fundamental thing, or we can see setup before we apply our trigonometric function. Here is our right triangle that we can apply our triangle trigonometry. So here is our right triangle. And what is the first step? Main first step we need to do when you have a right triangle? Well, we need to set our main angle that can define all of our positions of our trigonometric functions, and then label every single size using that main angle. So what it means by that is we need to set a main angle, and this is just an example. So let me erase this for more spaces. So I will basically set our main angle as right here, and I will call it as our x degrees. And the reason why I set it as the x degrees, not exact values, because we know that x value is a variable. Which means it varies or changes depends on times. And we don't know what the exact value of our x degrees right now. So here is our main angle that defines the position of our size or the length of each size. So if you label every single size using this pattern of our main angle, what about this side right over here? So we know that there are totally 3 sides. We need to fill in or label in our right triangle or whatever that triangle will going to be, because it is a triangle formed by the 3 sides. What is this size that I'm pointing out going to be? Well, we know that we are always having our main angle as the main position that defines our types or size. So this side is opposite with our main angle, so we note it as the opposite side. Or we'll just note it as the opposite, because of our small spaces. Now let's think about what is the side that I'm pointing out we're going to be. Well, it is the side that is close to our main angle, like the opposite side. So we'll just call it as the adjacent side, which means the close side with our main angle. Then people might confuse and have a question like this. Well, we have our main angle x degrees right over here. What about this length right over here? This is also close to our adjacent side, where we can apply our adjacent side since we knew that we applied it to this side right over here. And so how can you make a discrimination between each angles or sides? Well, we know that we call our adjacent side close to our x degrees, and we will call our adjacent side that is also adjacent to our 90 degrees, except for the opposite side. Then people might have an issue with this. Then how can you call this side right over here? Well, we will call it as the hypotenuse, as we had talked about this in a lot of videos. We will call it as the hypotenuse. And what is hypotenuse? It is the longest side in our right triangle. And how can you think about or define our hypotenuse in our right triangle? Well, it should always be opposite with our right angle, 90 degrees. This is what the hypotenuse will going to be. So using this size, we can think about 3 triangle trigonometric values, our sine, cosine, as well as tangent. The first thing that we're going to talk about is, so this will be our trigonometric values. This will be our trigonometric values. And the first thing will ask us, what is the sine of our x degrees? And another most important thing that if you want to apply our trigonometric values, we need to always have our main angle. And our main angle in this case will be x degrees. So the definition of our sine x degrees, every single trigonometric or triangle trigonometric values should be formed by a fraction. Which means it should be formed by a numerator and denominator. In the numerator, the definition of our sine of x will be the opposite side over a hypotenuse. And again, what is the hypotenuse? Well, the hypotenuse is the longest side in our triangle trigonometry, or whatever that right triangle will going to be, but it should be always opposite with our right angle. So this is a definition of our sine of x degrees. It is opposite over our hypotenuse values. Now let's think about the second one. What is our second one going to be? Well, it will going to be what is the cosine of our x degrees. What is the cosine of our x degrees? And we can highlight it that to remind ourselves that it is one of the most important, triangle trigonometric values. Well, the definition of our cosine of x is a little bit different with our sine of x degrees, but they still have their own similarities. The main similarities that the sine and the cosine has is that In the numerator, cosine of x is the adjacent side, unlike the first one where it is a sine of x degrees. But in the denominator, it should also be a hypotenuse. What was the hypotenuse definition again? It is the longest side in our right triangle. It is the longest side in our right triangle that is opposite with our right angle. The main difference between our sine of x and the cosine of x is they all contain their hypotenuse in their own denominator. Now let's think about the last one, which is a little bit unique for us. What is the tangent of our x degrees? Well, tangent of x is obviously going to be different with sine and the cosine, even though they all have similarities between them. What is a similarity that the all trigonometric function has? Well, they're going to be formed by a fraction, denominator with the numerator. So tangent of x is a little bit different with our sine cosine. In the numerator, there will be an adjacent side. Now people might think that isn't it similar with that cosine of x? It is different. In the tangent of x, there will be a opposite side, not a hypotenuse, unlike the cosine of x. So this is what it will going to be. In the numerator, it will going to be an adjacent side. And denominator, it will going to be an opposite side. This is what the tangent of x degrees will going to be. The tangent of x will be adjacent side over opposite side. This is what the triangle trigonometry will going to be. And what was the triangle trigonometry? It was a thing that we had to know. Firstly, that we need to know in order to solve for this question, because this question is basically about solving the applying our sine values, which is sine of 2x, to our triangle. Because the only reason why we can know that it is a problem about the triangle is because there should be always two things in our trigonometric functions we apply to our triangle over graph. So let's think about the case. When is a case when we apply our triangle trigonometry to our right triangle? When they gave us the angle values. Now let's think about the second case. Where should we apply our graph value? When they gave us the variables, which means like x or y, the changes or varies depends on times. This is the format of our trigonometric function we're going to be. And how did you know it was a triangle question? Because they gave us the bracket plus variable, which means they should be a angle. So we are applying this to our triangle, which is the most important thing in there will be an angle. So this thing right over here, these three things will be what we call triangle trigonometric values. Now before we go to the second step, people might ask us, hey, it's a little bit weird then comparing to our sine and the cosine, because the tangent of x contains adjacent side and the opposite side. Can we simplify this even more? We can simplify it. We know that the adjacent side's main I guess representation will be our cosine of our x degrees. And what is the main representation of our opposite side? Well, it will going to be a sine of our x degrees. This is what it means by it. So we can simplify our tangent of x in this way. Now we're obviously going to have a fraction numerator and denominator. In the numerator, it will going to be cosine of our x degrees. In the numerator, it's going to be sine of our x degrees. This is what the simplified form of our tangent of x will going to be. So if you make a big, I guess the little rectangle that shows that they are the trigonometric function values. So let me erase this for to see clearly, erase this in order to see clearly. So this is what we call a triangle trigonometric values. And this was the first thing that we had to know in order to solve this question. And the most important thing right over here was the values of triangle trigonometry. So, as we finish this, we have finished the first thing that we had to know in order to solve for this question, which was properties of triangle trigonometric values, sine, cosine, as well as tangent. Now let's go to the second step we need to know. And we know that people might think that, hey, this is originated from our Pythagorean theorem. which means we also need to know how to solve this Pythagorean theorem. And also, the reason why we need to know Pythagorean theorem, so the only reason why we need to know Pythagorean theorem is because we know that this is a right triangle. We know that this is going to be our right triangle. And if you want to apply our trigonometric function values, what should we have? We need to have the lengths of our sides. But we don't have any lengths, such as we don't have this length, we don't have this length, also we don't have this length. And what is the easiest way to get our lengths when the angle, or we can say one side is given? We need to apply our Pythagorean theorem. And it is also the most important, I guess, theory in our triangle trigonometry, because it is the thing that originated our triangle trigonometry. So first, before you think about this, let's think about definition first and apply whatever the Pythagorean theorem will going to be. So what the Pythagorean theorem refers to, it means there is specific proportions. There are specific proportions between our sides, the lengths of sides, but in our right triangle. This is what it means. The formula of our Pythagorean theorem means there are specific proportions between sides in our right triangle. So, what is the formula for our Pythagorean theorem? So, what is the formula for our Pythagorean theorem? Well, before you think about the formula, we need to think about its variables. So, there are variables A, B, and C. The A will be the legs. The B will be the legs, as we have talked about this in a lot of videos. And the C value will be our hypotenuse. What is our hypotenuse again? It is the longest side in our triangle. And since we know our ABC, we define our Pythagorean theorem in this way. A squared plus B squared is equal to C squared. Which means when you convert this into a letters, it means legs squared plus another legs square should also be a hypotenuse square. This is what the Pythagorean theorem will going to be. So this was what the Pythagorean theorem was, and we talked about the second one, which was the definition formulas or origin of Pythagorean theorem. And if you remind yourself, why do we need to use Pythagorean theorem again? Because this is a triangle trigonometry. We always need to apply to our right triangle. And what should we do when we don't know each side? When you have already one side, already one angle given, we always need to use our Pythagorean theorem. And Pythagorean theorem is also the origin. It is also a origin of our triangle trigonometry. So that's why we always need to learn what the Pythagorean theorem is before you think about the values of our triangle trigonometry or trigonometric function. And now let's go to the next step. What is the size of each trigonometric function values on coordinate plane? And this main point in here is the size of each trigonometric function values. So there will be two cases since we knew that it is a size. The reason is because we know the size includes either positive value or the negative value. Which means there are two number possibilities where the value can be either positive or a negative value. And the reason why we need to learn why this happens is because we know that this is related to our coordinate plane. What is the reason? Because we know the coordinate plane is formed by x, y, like we did right over here. And the x, y has its own signs. This side will be the positive side of our x. This side will be our positive side of our y-axis. This will be our negative side of our y-axis. So this will be our negative side of our y-axis, and this will be our negative side of our x-axis. And the only reason why we need to talk about it is we don't know where the locations of our triangle will going to be, and depending on the signs of the answers can be either negative or positive. So let's go to our third one. The signs, negative or positive, of each trigonometric function values. So if you want to have it, we always need to have, firstly, we need to have the coordinate plane. We need to have our coordinate plane. Also, we need to have our trigonometric function value. So trigonometry values. We can see there will going to be a x-axis and a y-axis that forms our coordinate plane. And there are, as we can see, the main example of our triangles in our coordinate plane will be mainly for this one types of triangle and this two types of triangle, and there are three types of triangle, and there are four types of triangle. These are the triangles that possibly can be in our trigonometric functions on our coordinate plane. And the thing that we're going to do is define the signs of our triangles. And what can be the triangle on our? The triangles can be on the quadrants. The first quadrant, the second quadrant, third quadrant, or the fourth quadrant. So here is our first quadrant. Let's think about the point right here. What is this point we're going to be? It's our x, y. What is the x, y sign we're going to be? Well, this one has the positive axis of x value, so will be x in the positive value. And it's also a y's positive value, so it will be x, y, they're all positive. And now let's think about the second quadrant. Let's say that this is our main one. We could say x, y. What is our x-axis sign going to be? Well, it is on the negative side, so the x value will turn to negative. And what will the y sign turn into? Is still our positive y value. Now let's think about the third one. Let's erase this from our spaces. And if you think about the third one will be x, y. If you just say this one will be our main angle, and as we can see, our x-axis is on the negative one, so it will be negative x, what is this axis will going to be? It will be negative y. So the x and the y should always both be our negative values when it is in the third quadrant. And for the last quadrant, if you just say that this is our main angle, x, y, what is the x value we're going to be? It will be a positive value. What is the y value going to be? It will be a negative value. So this will be x, negative y. So there are totally four types of our main angle where a triangle can possibly be on our fourth quadrant. And these were the signs of each quadrant or signs of each trigonometric function values. And so if you remind yourself what it was again, for the first quadrant, there should all of them x, y should be a positive. And for the second quadrant, the x value is negative and our y value should also be positive. And for our third quadrant, our x and the y value should always be a negative value. And our last one will be x, negative y, where the x value, our input of our function, should be positive and our output of our function should be negative. So this was what the signs of each trigonometric function values on coordinate plane were going to be. And the reason why we talked about this is because this question is basically solving about the sine of 2x on our triangle, and this triangle in our trigonometric or function should always be relying on our coordinate plane, formed by x and the y-axis. So depends on where the triangles are located, the positions of its answers will be varied. That's why we learned what the signs of each trigonometric function's values were going to be. Now let's get through our last thing you need to know in order to solve for this question. And we know that, as we can see, the sine of 2x, it is a little bit different with our normal trigonometric function problem because it has our 2. So there is a specific formula we need to know in order to solve for this question easily, not by plugging this in a calculator because it will make us think more complicated. And the last one we're going to be, we call this as the double angle formulas. this formula will be double angle formula, so we need to think about when it is used by. And the reason why we call a double angle formula, the right reason why we call our sine of 2x, for example, as double angle formula is because double means times 2, and in the x values there are 2, which means 2 times x of our sine value. So that's why we call it as our double angle formula, and our main angle in this case will going to be our x degrees. So using our there are two types of our angle formula. The first angle formula will be about the sines values. So sines values, the sines double angle formulas. So the sines value, which means when we're trying to solve the sine of 2x, and there are obviously going to be more formulas that we need to use depends on times, but we will be learning it when we face that questions. And this time it will be to solve the what is sine of 2x formula we're going to be. The sine of 2x formulas, which we call as double angle formula, will be sine of 2x is same thing with 2 times sine of our x values times our cosine of our x degrees. This is what the formula we're going to be, and if you write it more neatly, the sine of 2x is similar thing with this distributive property. We bring out our q values and we write sine of our x values times cosine of our x degrees. This is what the double angles formula will going to be in our trigonometric function problems. So this is for the science one, and we didn't learn it yet, but if we go more specifically about the another one, which we call it as the cosines values, cosines double angles formula, where the cosine of our 2x exists. The cosine of 2x is a little bit different with our sine of 2x. Its value will going to be 1 minus 2 times sine squared x. So this is what the value will going to be, 1 minus 2 times sine of square x. So if you write more way, we're going to be 1 minus 2 times sine of square times x value. This is what the cosine values when we apply our double angles formula we're going to be, but we didn't face this question so far yet. So using these patterns, which we call it as the double angle formula, we can apply this to our original question. And our original question was solve for a sine of 2x. So our original question was solve for our sine of 2x. And this will happen when cosine of our x degrees is equal to negative 2 over 3. And the main reason why they gave us the cosine value here is because we can simplify our sine of 2x into a double angle formula. And as we can see, this formed by sine and the cosine value. And we are trying to solve for the cosine of x values, but they already gave us the cosine value. So in order to solve for a sine of 2x value, all you have to do solve is sine of our x raised values in order to finish this question. What we're going to do is we need to apply this to our coordinate plane. And our coordinate plane is a plane that is formed by x and the y-axis, which is horizontal, and the vertical axis. And so we know that the cosine, so our cosines of our x value is equal to negative 2 over 3. And we might think about it in this way: when is the time that our cosine of x should be positive? Well, it's the time for the first quadrant, all of them x comma y is positive, so that can't be exist in our first quadrant. And for the second quadrant, we know the cosine is the thing that give us what the x coordinate we're going to be. It represents the x coordinate according to the property of our trigonometric function values. That means the last one where the x value is positive can't be the place where the triangle should exist. So there can be either second or a third one. But if you think about it, negative 2 over 3 will be like something like this, negative 2 over 3, where denominator can't be negative always, which means the y value, so the y value, which we're going to be our 3 value, in our tangent of x, we know the tangent of x is our adjacent side over a opposite side, which we're going to be x over y when you convert this into a variables. And that means the tangent in the y value should also be a positive. But if you think about it, the y value is negative, the x value is also negative. So this can be the place where the triangle can be located. So eventually the coordinate or the quadrant that the triangle can be appropriately exist will be the second quadrant. Now all you have to do is label our triangle and label every single size or angles that we are given and try to solve for the values of sine of 2x. The reason why this should be a main angle is because we know that our adjacent sides are negative 2, but this side is our positive side of our y-axis, so this can be a negative side, and this one is our negative side of our x-axis, so this should be negative 2, and this one should be something. And the reason why we can know it is by our values of our sine and the cosine values. And so we have already one more size left to solve it. And what will that sine going to be? We don't know yet, but we can just plug it as the y value, or I can say c value, and use our theory that we used. And why is the theory that we used? It will going to be a hypotenuse, which we call it as the Pythagorean theorem. This is the time we can apply our Pythagorean theorem. What was the Pythagorean theorem again? It was a squared plus b squared is equal to c squared. What was the a value? We can just set any of them. I will just set it as the x, which means x squared plus another side, negative 2 squared, which is 4, should be equal to our 3 squared, which is 9. In order to solve for our x squared, all we have to do in order to isolate is subtract 4 to the both side, and we'll get x squared. So we'll get x squared is equal to 5. And in order to solve for the x value, all we have to do is take square root, and we will get the x value is approximately going to be square root of 5. So our x value right over here will be a square root of 5 value. So this will be square root of 5, this will be 3, and this will be negative 2. And if you go back to our original question, it says to solve a sine of our 2x. So since we solved our lengths using our Pythagorean theorem, we'll be able to erase these things from our spaces to apply our basic trigonometric function problems. We are trying to solve for our sine of 2x. And what is our sine of 2x? When we use our distributive property in order to simplify it, it will going to be 2 times sine of our x degrees times cosine of our x degrees. So if we keep simplifying, what was the sine of x? Well, we still have our 2, and the sine of x will be, if you see that this is our mean angle, which is our x degree, the sine of x, what was the sine of x? It was opposite side over hypotenuse. What is the opposite side? It will be square root of 5. So it will be square root of 5 over our hypotenuse, which is the longest side, 3. That will be our sine of x. And then times what is the cosine of x? Well, cosine of x will be adjacent side over hypotenuse. What is the adjacent side of our x degrees? It will be negative 2. Negative 2 over hypotenuse, which is our 3. So if we simplify this, we'll be able to get what is the sine of 2x. So if we keep simplifying this, we will get 2 times square root of 5 times 3 times negative 2 over 3. If you multiply them together, this one will be 9 in the denominator. In the numerator, there will be negative 2 times square root of 5, and all of them times 2. So negative 2 square root of 5 over 9 times 2 will be what our answer of this question will be. And this one is the answer for the sine of our 2x values in our right triangle.